This is Swarfcast. I'm Noah Graff. I am very honored to be with Onome Scott-Emuakpor, founder of Hyphen Innovations in Dayton, Ohio. Welcome to the show, Onome.
Thanks for having me.
Okay, so just to start, I want the 2-minute explanation of Hyphen Innovations, and then we'll get into more of it later. Just a real brief overview.
Okay. With Hyphen Innovations, what we do is we make aerospace parts. We make them lighter. We make them stronger. We make them low cost, and we do that with unique out-of-the-box design. And we also use some really intriguing advanced manufacturing methods.
What kind of aerospace stuff?
Specifically to aerospace, our main interest is turbine engines and turbine engine structures. And when I say turbine engine structures, we normally focus on the 3 to 4 main structural sections. So the compressor section, turbine section, shaft, looking at some unique combustor design. And the reason why we're focused on the turbine engine is because we know that there's still a lot of innovation. There's still a lot of juice to squeeze out of that technology and advance it and improve the thrust to weight, so to speak, and do all that while also maintaining affordability with it.
I want you to back up a second. Give me the dumb 5-year-old explanation of a turbine engine and what it's going into.
So a turbine engine is what powers aircrafts. So your commercial aircraft, a lot of them are run with turbine engines. Even the propeller ones are run with turbine engine. It's just run with a turbo prop. And so a lot of turbine engines are used for the aviation industry, but there are also turbine engines that are used for power as well.
Right.
Because it's a great power generator. So we have power turbines as well. A lot of my focus has been with gas turbine engines and aviation. But there's obviously a lot of similarities with power generation as well.
Okay. So the research you're doing could be also used for other applications than aerospace?
Absolutely. That's one of the things that I like to tell people is that the physics is physics, and especially when it comes to structures. Things that are dynamic, things that move, get hot. They need to be cooled, and if they're moving, it's better that they're lighter weight and have less friction so that it does less work. And all these things are all the same, whether it's a car, whether it's an aircraft, whether it's for power generation, whatever the case is. If you have parts that are moving, if it's a home generator, if you have parts that are moving, somebody's going to want the weight to be less. Somebody's going to want the friction to be less. Somebody's going to look for a unique design. Somebody's going to want less manufacturing steps to make it cheaper. All these things are necessary in all these power systems. So certainly my work transcends turbine engines and aerospace industry in general.
Okay, that makes total sense. All right. I want to get some of your story. The thing I want to focus on in this interview that I think is so interesting is that you have a really eclectic background, and where you're from, various things you've done in the past, your interests in art, So I want to delve into that and see how this goes into the work that you do. So when you were really young, you lived in a lot of places. You tell me a little about that.
Yeah, so was born in Lansing, Michigan, and lived there for
And when were
a
you
little over
born?
three
How old are you?
years.
Okay.
1978, so 44. So I lived there for 3.5 years or so, and then moved to Nigeria and lived there for
And that's where your
about
parents are
6 years, maybe. My
Okay.
parents are originally from Nigeria, yes, but most of my siblings were born in America. And so we lived there for almost 6 years, and then from there moved to England, lived there for about a year, and then came back to Lansing, and I was there when I
Do you
was
remember what it was
10.
like at all living in
So
Nigeria?
I do, I do remember, but it was
Yeah, I mean, what do you remember when you're 7, right? But it's interesting. What First of all, why did you go back
right.
to Nigeria?
Work. My dad went back to work. My dad's a medical
Okay.
doctor, so he went back to work and teach at the university back home. And the reason I was in Michigan in the first place is because he went to Michigan
That's where
State,
he studied medicine, or that's where he
and
was a professor, or both? Or
that,
interesting.
both, both. That's where he studied. That's where he studied medicine. That's where he was a professor. Uh, that's where he practiced, and then moved to Nigeria and did the same thing there, and was there for 5 years, and then decided to move back to
Very
the
interesting.
U.S.
Uh, okay, so you you know, granted, it's until you're 10, but still, I think it's does something to somebody's brain when you're living in another place, maybe speaking another language, etc. Um, and then you grew up in Lansing, Michigan. Uh, Big sports traditions there, Michigan State, etc. And you played basketball. When did you start playing basketball, and where did that take you?
I started playing when I was 10, uh, and it when I first started playing, I really wasn't
How
that
tall are
good.
you?
It was
6'7".
6'7",
Okay. And so, what's your position that you played?
small forward. Yeah, I mean, obviously in high school and in grade school, the biggest kid out there, you always put him at center. That was a thing back then. They don't do that these days. But back then,
Sure,
it's like,
sure.
oh, you're a center. You just stay
Go
stay on the
bang.
block, grab rebounds, do whatever. But yeah, but like it's as I matured, my natural athleticism, kind of had me gravitate towards small forward. Uh, so pretty much was training and playing as a small forward probably by since I was, from 16 all the way through college.
Okay, so where'd you go to college?
Wright State.
Where? Wright
Wright
State?
State.
Okay.
Yeah.
And
Yep.
did you have any aspirations of going to the NBA, or did you figure college was the sort of your ceiling?
Everyone has aspirations of going to the NBA. So
Not
I'm going
everybody, but
to. Well, everyone that plays at that level has aspirations to go to the NBA.
Wright
But at
State is
some point,
Division 1, and
yes, Division One. But at some point, you have a reality check, and you think, all right, that's probably not in the cards. And I had that reality check, but I still had aspirations of playing professionally
mhm.
because you know there were a bunch of former teammates that played professionally, or a bunch of guys I played against growing up that played professionally, and they'd come back and they'd tell the stories of
Sure.
playing overseas and just the culture. I mean, we've talked about this before. It's just experiencing the culture in Europe. These guys would come back and start telling us about it. It's like I was like, oh, there is a place I can play professionally that is just as cool as the NBA. Probably, I mean, obviously not as lucrative, but just as cool. So for me, it was like, well, that's
right. And I mean,
that's my backup plan.
Sure, and you're African, and you're lived in England, so yeah, I mean that it probably didn't seem quite as strange. What did your parents think of that being one of your goals?
They were okay with it.
They were okay with it.
Yeah, my dad's very good at giving advice and letting you do with it as you wish.
Okay.
So it's one of those things where he's like, if that's what you want to do, great. But I think you should have a backup plan just in case.
Sure.
And then that was it.
And then you were also into fine arts, correct?
Mm-hmm.
So what kind of fine arts did you do growing up, and what did you might want to do when you were a kid, besides wanting to be a basketball player? What things were interesting to you in school or later on in life?
So for me, when it came to art, it was just mainly sketching. Like I love to sketch, and so I went into high school just mainly sketching. Then when I got to high school, you get introduced to art classes that broaden your, artistic, capability. All of a sudden, as I'm painting, I'm using watercolors, I'm using color pencils, I'm painting with pastels, and painting with oils, and it was like, I was like, this thing that I, have been naturally good at as a kid, just has expanded to all these other mediums, and it's just like, I was like, this is it. This is what I want to do.
It was exhilarating. Yeah.
Yeah. I want to sit in one place and paint or draw, whatever it is. If I'm not playing basketball, I want to paint or draw.
So when you went to Wright State, were you an art major?
I was not. I was not.
Did you take art classes?
I did take art classes because I went into the mechanical engineering field. I didn't have the opportunity to draw and paint and experience those things like I used to. So I decided, all right, I'm just going to take art classes as electives.
Were you also pretty good in school or interested in that stuff in high school, engineering, etc.?
Engineering, not so much. I didn't really know what an
and all that.
did. I didn't even take physics in high school.
Mm-hmm.
I took the mandatory classes. I took the maths. I took the languages.
Right, but you were probably in honors classes, and I mean,
I was not.
Really?
I would have not. No.
I would have.
I was not. I was.
You
not
have good genes. Class. Your dad is a doctor. Why do you think you weren't in honors classes?
I didn't apply myself.
Okay.
I wasn't interested. And it's one of those things, one of those kind of like self-discovery things as you get older. It's like, I realize if I'm not interested, if I'm not emotionally invested in it, I'm not going to do well in it. And that was pretty much with school. With
your
with
parents
English.
Didn't just sort of expect it? Like, duh, you're smart. You're going to honors classes.
Yeah, my dad did. He's not overbearing with his advice. He's one of those, you can do better, I'm disappointed, and just kind of walks away.
Interesting.
And then it's up to you. It's like, all right, maybe I can do better, But no, I just I wasn't interested in doing homework. I hated homework. I don't think I ever did homework in high school. I did homework 5 minutes before class.
And that's just because it wasn't interesting to you.
It just wasn't interesting to me. Math was kind of interesting, but the weird thing about math, why it was interesting to me, because I liked the challenge of seeing how well I could do on homework if I did the homework 10 minutes before class.
Interesting.
And
Well,
so it was just, I
and were you able to do a decent job?
mean, I got mostly B's in math.
All right.
uh, I got some C's, but considering that I was doing homework, 5, 10 minutes before class, I think getting a C is pretty good.
Yeah, it was probably too easy for you. Um,
Yeah.
okay, so you're in college. You decided what made you decide to go do engineering then? If you were sort of a slacker in high school, and I can only imagine. I mean, having been to college myself, like the idea of being a student athlete and uh, taking classes, whatever. I mean, I don't know how anybody has time to do that. Like, you really have to be ambitious, and to do engineering, that says something about you that you were efficient, probably.
Yes,
um,
that's
so,
the
what made
word.
you go, I want to do this? If your interests before were fine arts and sports, and now you're
Mhm.
just like, well, this sounds like a good trade. I'm going to do that, or what?
It was so my dad really understood me and understood uh, what I could do and couldn't do, and so uh, as I was applying to all these universities, I kept putting down fine art. On my questionnaires, I was getting recruited. I was putting down fine art, and before that, I just taken
And they didn't
the
really
AC.
care, right? They just wanted you because
Yeah,
you were 6'7" and
they
athletic.
don't. Yeah, they prefer you pick an easier degree. No, no,
Right.
because they understand the burden. Like you said, they understand the burden of what they're
Particularly
going to
being a
ask you to
basketball
do.
player.
Yeah,
Yeah, you're
like they
traveling.
like absolutely they understand it. So they're like, all right, if you take this major, I know those professors understand what burden you have and are going to be more lenient on you. Like they're like, if you go into engineering, you are on your own. I don't know those guys. I don't know those professors. It's a really hard degree. We prefer you don't take that. you know, it's just
But
and
you
it looks
just
good
said,
on.
so your freshman year, when you're trying to figure it out, you're just like, engineering, why not?
Well, my dad was the one that was because prior to putting down all these putting down fine art on every questionnaire, I taken the ACT and I did terribly on it twice. Terribly.
Why? What'd you get?
But on
Like 18 or 20 or?
19,
Okay.
19 twice. But on the math part, I got like 30 something,
Nice.
which, you know, who gets 30 something on math but a 19 overall score, all right? Like it didn't make any sense. And so I remember my dad, kind of like don't put fine art as your major. That's not a major. Come on. So he was like, I'm gonna go sleep on it and I'll tell you what you should do. So he was like, I had a dream. You should put down engineering.
Did he use the word should?
Yeah, he said should.
Mm, I'm
And I was like,
anti-should.
and I told him, I was like, I don't know what an engineer does. And he said, go to college and you figure it out. That's what college is for.
All right. So you said, what the hell? I'll take
Yeah.
like the pre-engineering classes, and then you thought it was kind of fun.
It was easy to do.
Really?
I didn't. Yeah. Yeah. Because
Nice.
again, my dad understood my my abilities. He knew what I could do, what I couldn't do, and he was like, this guy's a slacker. Let me give
Yeah.
him let me give him the right
Do,
guidance to be successful.
do you think
And
that
so
I know, I mean, we're just lingering on things, but Mike, do you think one reason in high school you may have had lack of motivation was because you weren't in honors classes, and maybe if you were around different peers and pushed differently, uh, you might have found the material interesting? Or you think it was just sort of, this was the way your mind was at the time?
that is a question that I often ask myself, and just in general when I think of other people, is would a challenge have made me rise to the occasion, or would a challenge have made me say, "This is too hard. This is stressful. I don't want to do this."
Yeah.
And the answer to that question is I don't know.
Right. Well,
Like I have
because your
no
brain
idea.
changes as you get older. So,
Yeah,
it
yeah.
could have
So
been that.
it's uh, but yeah, even still, like early on, taking the math class, because you start off taking math classes. You don't. Well, I should take. No, let me rewind. At Wright State now, you have this engineering intro class that
Where is
kind
Wright
of
State?
Dayton,
Dayton. Okay.
Ohio.
Okay.
Yeah. So you have these classes that prepare you for being an engineer. Like you get into them. This is what an engineer does. So it essentially is like geared to spark your interest in engineering. Like, is this really what you want to do? And it ends up kind of being like a weed out class where some people get into it and decide this isn't what I want to do. So I didn't have that. I went into math. You do math, then you do physics, and you do that for 2 years, 2.5 years, and you jump into engineering. So I was just taking these classes that I could pass, these math classes, these physics classes. I knew I could take them. I knew I could pass them. And so I did that for 2.5 years. It wasn't until I actually started taking engineering classes that I thought, well, this is kind of interesting. But still, there were just like problems, and there was some connection to the real world, but it was weird,
Right.
problem
It wasn't.
solving.
It didn't seem. It wasn't like conceptual enough.
Yeah, yeah. But it was interesting enough for me to do well in. Uh, it wasn't until I actually got a job that I actually was like, I now see where all the math is going. I now see where all the physics is going. I now see where all these classes are going. I now understand what they mean. Now all of a sudden you walk into a class and they say, this is vibration. And it's like, oh, no, I've been working in a vibration lab. I know what vibrations is. This is going to be an exciting class. And sure enough, I got an A in that class, which was supposed to be a really hard class. And like, kind of like, the hard, it's supposed to be the hardest class in undergrad. And I got an A in that class.
And you thought that the lab was extra interesting because you understood the theory behind it.
Exactly. Once you can make that connection, it changes. It changes how you work, how you go through wanting to learn the subject. Once you can make the connection, if you're just solving problems and it's like, oh, why am I solving this problem?
Yeah, well, I think that's what bogs people down. They're just the mechanics of it.
Yeah.
And they're, so it sounds like fortunately, the mechanics weren't a big deal to you. The equations, you were able to just do that without that much pain and get through that, because that's probably what stops people in the first place from getting there. Do you think that the way engineering is taught in college and the way physics is taught based on all these formulas and just numbers, and do you think that it should be changed, like, because maybe people get turned away because they don't even know what the practicality of it all is?
If you'd asked me this question right when I graduated from undergrad, I would say yes. But I know that Wright State and some of the professors that I've talked to, just in this area, have tried to change their curriculum to be more realistic and incorporate more real world problems.
Mm-hmm.
So I think there are a lot of current professors right now who graduated the same way I did, and essentially saying, I got tired of doing these, silly problems that
So you
didn't
think
seem
it's a
to.
good thing?
So yeah, it's a good thing because a lot of the guys graduate like I did, where they're like, "This is dumb. I wish somebody could turn these problems into real world, activities, so that
Yeah,
kids could be more excited." And I think a lot more universities are starting to do that.
that's smart. When I was a freshman, I I was just like, and I wasn't bad in physics in high school, but I was just like, I do not want to do this crap. Um, I took a class called Physics for Poets, which it was really cool. I bet you would have thought it was cool. You learn about you learn about Einstein and Fermi and all this stuff, and it's more just like here's what it was about, as opposed to all right, here's some fractions. Now cancel out the zero over here and the zero over here, and I'm just like, what, you know like
I took a class at Ohio State that's called the history of math.
that sounds interesting.
That was the most fun class I ever took, and it was a grad class. It's like one of the most fun, one of the most engaging classes I've ever taken.
You think if they
Uh,
offered something like that in undergrad, that could change lives,
I think so.
or even
'Cause, I
high
mean,
school?
just yeah, in high school definitely. Because I mean, just learning about that stuff, just learning like uh, you know what Isaac Newton was going through during the Black Plague when he decided,
Yeah, that stuff's
I'm gonna
fascinating.
lock myself up in the shed for 2 years, and oh, by the way, I'm gonna invent calculus and
So
physics.
probably if you had had that in high school, it would have been even. You would have probably wanted to try harder. You would have been interested.
Yeah, like I mean, like those stories are fascinating, just because when it tells the history, it doesn't tell the history by giving you math theorems. It tells the history
Yeah,
of talking about the person and what that person was going through when they came up with what they came up with.
that's
You know,
fascinating. Yeah,
it was
versus,
it was great.
I mean, math. I I went out with this math professor one time for a couple months, and you know, she's like, yeah, people don't understand like the stuff you're learning in math class. It's not even math; it's arithmetic. It's just numbers, and numbers isn't even really what it's about.
Yeah, right.
Uh, um, Eventually, you got, it seems like you found more and more meaning in it, more and more purpose in it. It wasn't just something that was smooth; it was something that actually meant something to you. So then what happened after college? After you got a PhD in
hmm
engineering again. So what does one do with a PhD in engineering? Or did I skip a bunch of important things?
uh, it depends on what you consider important.
Did you work before you went to get your PhD? Did you work in a
No,
place?
no. I went from undergrad to grad school.
What's your
Um,
opinion
like,
of that?
my opinion of it uh, is personal. For me, I always said that if I stop going to school and I get a job, I'm not coming back
Uh-huh.
because I hate sitting in classes.
And
I
you
just
thought there was something to be gained by staying in school.
there was something to be gained, and also I just didn't really know what I wanted to do.
Ah, I think
So it
that
was like,
happens a lot with academics.
I didn't know what to do. It was like I got done with undergrad. I was like, I don't know what I want to do, and I got offered, I got offered to go to Ohio State, with engineering. You get stipends. It's
Ah,
not like
perfect. It's not like business school where you have to pay for it. They pay for
yeah,
you. Beautiful.
they pay for you and then they pay you, which Uh, Now that I'm on this side, it's actually cheaper labor to to pay a grad student than it is to pay, somebody professionally. So, uh, but still, they pay for school, and then they pay you, and it's like, and what they were paying me was more money than I'd ever made
And
in
it
my
was enough
entire
to live
life.
on?
Yeah, it was more money than I ever
You
made,
didn't have to like
like ever.
give plasma or something.
No, like it was great. I got my money and I bought a car.
Yeah, well, that makes
So
sense. If you don't mind school, you know.
yeah, yeah, and and one of the selling points with grad school is it's less classes. With undergrad, you're taking 3-4 classes a semester.
Yeah.
With grad school, it's like, you know,
Is grad
if,
school
if
less
you
of a
learn,
grind than undergrad?
it depends on who you ask. For
And
me, yes, it was less of a grind because I was taking 1 or 2 classes. No, well, we were on the quarter system back then. I was taking 1 or 2 classes a quarter. Like one class, like you know that's nothing compared to what you're doing in undergrad. And
you weren't playing
the rest,
basketball anymore.
and I wasn't playing basketball. I was taking one class and I wasn't playing basketball, and the rest of my time was dedicated to doing research, which the research part of grad school was easy to me.
Okay.
There are some people that the class part of grad school is easy and the research is hard. So depending on who you ask, if you ask the guys who think that classes are easy and research is hard, they're going to tell you grad school is really hard.
Yeah.
And if you talk to guys who, naturally just kind of fall into the research and hate classes, they're going to tell you grad school is easy because you don't take that many classes. You're more so focused on the research that you need to do. So for me, it was, it's like, you know, I gotta, do
And you were
like,
doing aerospace engineering by this time. This was like this
well,
is
it was technically a mechanical engineering degree, but it was on understanding structural assessment for the purpose of aerospace components.
okay. So you finally get your PhD, you've done all this research, you're a career academic, you're like mid-20s, and then you're just like, all right, now I have to like do something with this.
I still didn't know what I wanted to do, which there's a place for that. It's called a postdoc.
All right, but you said screw that, I'm going to like enough of this class stuff.
Yeah. When I got my PhD, I had nowhere else to go.
Besides teach, you know.
Yeah, besides teach, I had nowhere else to go
So then you worked
besides teach, get a job.
you worked for the what for the Air Force?
Yeah, so I actually got my postdoc. My postdoc position with was through the Air Force, or I should say, it was through the National Academies. But I was working at the Air Force Base. So the same place that I worked at in undergrad, the same place that I did my graduate school research, is where I landed for my postdoc. So even though I was employed by somebody else, I was still doing the exact same thing I was doing in grad school,
Research.
which was research.
And how long did you do this research?
Uh, Year and a half.
Oh, okay.
Yeah, I was there a year and a half, and then after that, I got converted from a postdoc contractor to a full-time civilian doing research in the same lab.
Okay. And how do you feel about research?
I love it. I mean, that research essentially allows me to engage in the no in my creative side. It allows me to essentially do art with
Yeah.
science and engineering.
All right. I want you to articulate about that. How is research getting you to use your art muscle?
So when you think about art, it's like you're given a blank canvas to create something. Like it's, and that's kind of generalizing it. Obviously, there are different mediums that you can use. But, you're essentially creating something from nothing. Even when you're taking a picture, you're creating something from nothing. When you're writing, you're creating something from nothing. When you're doing research, you essentially have nothing.
Really?
Like someone someone is essentially saying, like, I can give you an example. Is like when I first got hired, I asked my boss, I was like, what am I supposed to be doing here? Like, what's my job function? And he said, just keep doing what you do, and walked away. That was my job. Which, what does that mean in any other profession? Like, just keep doing what you're doing.
So what were you doing? I mean, to me, research sounds like you're building on other people's research. So you're doing something with something.
You have, like, you're given, like, for instance, there's a turbine engine there. You're supposed to do research on turbine engine. Exactly what research are you supposed to do? Like, there's not.
So you had to come up with an idea, like, what can I?
Yeah,
how can I improve it? How can I?
Exactly.
They didn't tell you. Hey, this is a puzzle we've been trying to crack.
There are some cases where they do that, but in a lot of cases, you have to just essentially look at this and say, what puzzle can I crack? Like, what improvements can be made? Like, everything can be improved, right? Like, so you essentially have to look at it and say, what improvements can I make? Now, the next step of that improvement, there's no roadmap for that, right? And so you have to essentially figure out where the next step is, and then where the next step from that is. So as adding on,
I think. Sorry to interrupt. I see what you're saying now. That's where the creativity comes. Of you don't have the structure. You don't have. Here's your assignment. You have to figure out. I'm surprised at that. I would have figured they would have said, "We need more power. We need it to be." And you have to look at it.
And with that, even with if you say I need more power, how? Like, where do you start?
Okay, so how do you approach it, and how does your artistic muscle help?
So for me, it's someone says they need more power. All right, well, where do you get power from? You can get power from making it easier to do work. You make it easier to do work, and you can generate more power. How do you make it easier to do work? You can increase temperatures. You can increase pressures. How do you increase temperatures? Well, what if the material that you have, its temperature is already at the limit of its temperature? How do you then increase your temperature? Well, now you got to get creative and figure out a way to increase temperature, right? And one way to get creative is by introducing new cooling mechanisms. Well, how do you introduce new cooling mechanisms? To do that, you have to essentially recreate the component to be able to intake new cooling mechanisms. So it's kind of like, and then you get to that, and it's like, all right, well, great, I just figured it out. Then it's like, how do we manufacture this?
Right.
So now that's a new problem, figuring out how to manufacture this thing out of this material to have this new design to be able to, incorporate new cooling mechanisms. So it's like each step, like, you're just essentially tweaking stuff. And then once you tweak it, you run into the next problem and the next problem. So a lot of what I do is essentially that, we're looking at stuff, and, people say, we want the life to be longer. All right, well, how do you make the life longer? Reduce stresses. Well, how do you reduce stresses? You reduce vibration. Well, how do you reduce vibration? It's like, you add more material to it. It's like, all right, great. Well, you just added more material to it. Now it's going to be working harder
wow.
than it was before. Now it's less efficient. So now you just made it less efficient than it was before. So now you just added a new problem. So how do you now fix that problem?
How much are you leaning on other people's research for your own research? how much are you inspired by it? I mean, art, um, I've been listening to this book by Rick Rubin about art, and what he says is that everything is bitten off other people, and that's perfectly fine. You're going to do your Onome version different than some other engineer. I was going to say different than Noah, but I haven't come up with anything rocket science. So, is this something you do? Or are you constantly looking at other people, or are you just kind of trying to come in from your own blank slate?
I'm constantly getting inspiration from other people. I'm constantly looking at what other people are doing. More, and even to kind of expand on that, I'm constantly looking at what people are doing outside of my industry.
Nice.
So it's kind of like
So what are the inspirations that you take it from?
Well, that's a loaded question.
Do you not want to give us your secrets, or?
No. It's just a little bit of everywhere.
I mean, are you watching like a Star Wars movie, and you're watching the Millennium Falcon, and you're going, wait a second,
or watching So one example I can give you. So there's a patent that the Air Force is releasing to me that I helped develop while I was a civilian in the Air Force. And the way we came up with that, we were in a meeting and we were talking about laser powder bed fusion additive manufacturing. And in this meeting, everyone was talking about how it's beneficial for complex cooling passages. And they're going on, and it was like and the guy sitting next to me tapped me and he said, well, what if we just left the powder in there and it suppressed vibration? And then I laughed and he laughed, and then we both stopped laughing and just kind of looked at each other like, well, what if?
Yeah.
And the next day we're both of us go back to the lab and we start working on this thing, and all of a sudden it's the what if turned into something. And so it's just, it can be, inspiration can come from anywhere.
Yes.
Like it can come from people arguing in a meeting while you're sitting in the back, just watching these people argue. It's like, so, for me, it's just, I just pay attention. I'm constantly thinking of how I'm going to solve the problem. There are lots of problems that can be solved enough to keep you thinking all day.